Here you have a square defined by a kinetic edge. So you have a random dot kinematogram. Now what I'm going to do is to replace the black with gray so that the gray is equiluminous with the fine-grained texture in the background. Okay, so instead of black against texture, you have light gray against texture, with the mean luminance of the gray being the same as the texture. So now you're clearly seeing a square defined by motion parallax. Now I'm going to match the luminance of the pixels, and you'll see what happens. This is similar to an experiment done by Ramachandran and Gregory, who used equiluminous chromatic borders instead of texture borders. You notice there's a dramatic loss of the square. You still see some impression of rubbery motion. Some elements seem to move, but the sense of an oscillating square vanishes completely, suggesting that image segmentation based on motion depends on luminance contrast, will not accept texture edges. And Gregory and I had observed exactly the same thing with chromatic borders, except in that case, even the motion deteriorates. So here there is some reduction of motion, but what's most striking is the dramatic loss of the square. If you use chromatic edges, motion is reduced considerably, and again the square is also lost completely. Now I'm again adding luminance contrast, and this restores the impression of the square. Very vivid impression of an oscillating square. If I make it equiluminous, again the square disappears. So what we are arguing is that image segmentation based on motion is especially sensitive to luminance contrast. It needs luminance contrast and fails at equiluminance.